Hi, this is Adam Wise, application scientist with Andor in the US. Today I'd like to talk about the somewhat confusing topic of preamplifier gain, aka preamp gain, aka, I believe, conversion gain. In many of our cameras, specifically here in Ixon Life 897, but also most of our CCDs in general, there is an acquisition parameter called preamplifier gain. And let me open up the acquisition menu so you can see it here. It's right here. So what does this actually do? This lets us control how many electrons on the sensor it takes to make a count, a unit of the analog to digital converter, which I'll call the ADC from now on for brevity. So the analog to digital converter is what converts the analog charge in our sensor into a digital number that we can actually use and work with. So by default, the unit that we'll see in our data is counts. Let me close this. And you can see that here's the data, 590, and this is in units of counts. That's in ADC counts, analog to digital converter counts, basically digital numbers. And the question is, what's the relationship to that, to the actual charges that we're measuring? So you can see here I've clipped out a piece from the spec sheet for this, or for the performance sheet for this camera. And you can see that here's the actual CCD sensitivity in electrons per A to D count for each setting. So when I go back to that acquisition menu, readout rate 17 megahertz, gain 1 means I'm going to take 15.2 electrons to make one A to D count on average. So what's the purpose of this? The purpose of a selectable preamp gain is twofold. So first, some of the readout noise that comes in when the image is read out is going to be in units of counts. And the fewer electrons it takes to make a count, that is, the higher our gain is, the less that noise will overpower our signal, which is sitting on the chip in the form of electrons ready to be read out. So let me just show you that real quick. I'm going to use a relatively short exposure, turn off EM gain, just so you can see the read noise. If I have EM gain on, that will basically obliterate the read noise. So I want you to see it just so you can kind of get an idea qualitatively of what's going on. So let me go back to the acquisition setup and just stress this point here. So this is preamp gain 1, which is 15 electrons per count. Take an image. So you can see I've brought in some read noise, and let's just simply change the preamp gain to a higher gain, gain 3, which is 4.89 electrons per A to D count. So if we have a certain noise in A to D counts, it's now less electrons, and it's going to compete with our image on the chip significantly less. So let's see how that plays out. Oh yeah, very nice. Of course, once I turn the EM gain back on, even at a moderate level, we don't really need to worry about that, but just I wanted to make the point. So then it might make you wonder, why not operate at the highest preamp gain all the time? That is to say, why not require the smallest number of electrons to generate a count? Well, if it only takes 4 to 5 electrons to make a count, and we only have a range of 0 to 2 to the 16, or about 65,000 counts available on our 16-bit analog to digital converter, then we're going to be limited to 2 to the 16 times 4.89 here, or about 320,000 total electrons that we can measure without hitting the top of our range and losing count. That might seem like a lot, but we actually have a capacity in this camera to hold 800,000 electrons in this camera's gain register. So that's kind of where it's going to sit after amplification, but before readout. So if we want to access that full range of the measurement and get the highs as well as the lows, we need to pick a lower gain. Say here we could go as low as 15.2 electrons per A to D count. That's to say it's going to take about 15 electrons to make one count in our data, to make one click in our analog to digital converter. That would give us the ability to measure about 900,000 electrons, which is enough to measure everything we can make, so to speak. So I'm not going to take a big excursion right now, but I'm going to probably record a video talking about saturation in which we'll see that more clearly. So again, if you have more questions, feel free to send me an email at a.wise@andor.com or visit the Andor website for more information. Thanks, and have a good week.